I'm Anil Kumar sharing with you an excellent question on derivatives of absolute function. This has been posted by one of my subscribers who is probably preparing for IIT JEE. Let me thank all of you for participating actively and posting such good questions. We need to find derivative of p of x, which is equal to x minus 2 to the power of 5 divided by x minus 5 to the power of 4. Now to begin with, let us write them as a piecewise function. So what we can do here is that we could write x minus 2 absolute value to the power of 5 as equal to. Now this value could be negative or positive depending on the value of x, right? So we could write this as minus of x minus 2 to the power of 5 when x is less than 2, or x minus 2 to the power of 5 when x is greater than 2, right? So let me for the time being take this less than equal to. As far as absolute value of x minus 5 to the power of 4 is concerned, now if I do negative, then since this power is 4, it is going to be always positive, right? So this function basically is x minus 5 to the power of 4 for all values of x, right? Well, for some of you, if this concept is not very clear, let's get back to the absolute value of x, which is equals to square root of x squared, right? Then what is square of absolute value of x? It is going to be x squared. You get an idea, right? So if we have even powers, then it will be kind of similar situations, and therefore I could write like this. Is that clear? Right? Okay. We also learned that the derivative of absolute value of x is x over absolute value of x, where x is not equal to 0. Right? So all these derivatives are defined at all the points except for wherever there's a corner, right? So straight away we know for these functions that x is not equal to 2 or 5. Is it okay? That is a point where derivative is not defined. Okay. So that leaves with a situation in which basically we are working with two functions. If you see, right? We have first function for x less than 2, the other one when x is greater than 2. And the function here, when less than 2, could be defined as minus x minus 2 to the power of 5 over x minus 5 to the power of 4. Is it okay? And the other one will be x minus 2 to the power of 5 over x minus 5 to the power of 4. Right? So let's call these functions as f of x and g of x. Right, so I'll split this function into two parts where x is less than 2 or greater than 2. We clearly know that it's not differentiable at x equals to 2 or at 5. Is it okay? Now the idea is that both are very similar functions except for this negative sign. So we'll work with the derivative of this function, right? So we can write this as g of x equals to x minus 2 to the power of 5 over x minus 5 to the power of 4. Now, it's a simple quotient rule, right? So this implies that the derivative of this function should be equal to denominator square, which is x minus 5 to the power of 8. The derivative of this is 5 times x minus 2 to the power of 4 times denominator, which is x minus 5 to the power of 4, minus derivative of denominator 4 times x minus 5 to the power of 3 times the numerator x minus 2 to the power of 5. Is that clear? So we can now write g dash x, we are doing only 1/2 of it, is take whatever you can take as common. So we could take x minus 2 to the power of 4 and x minus 5 to the power of 3 as common, right? That leads with x 5 times x minus 5 minus 4 times x minus 2, right? And here we have x minus 5 to the power of 8. Now this can be simplified and we can get here x minus 2 to the power of 4 over x minus 5 to the power of 3 times, you could simplify this, 5x minus 4x is x, minus 25 and minus 8 plus 8, right? So we have x minus 25 plus 8. So that becomes the derivative for x greater than 2, right? Which is equal to x minus 2 to the power of 4 over x minus 5 to the power of 3 times x minus 17. Right? So this is g dash x. Similarly, we could write f dash x as equal to negative of all this, right? So we have negative of x minus 2 to the power of 4 over x minus 5 to the power of 3 times x minus 17. Does make sense to you, right? So that is how we could get the derivative of this particular function. Now, you could also have a different approach towards this. So we can write the derivative as, let me write down the derivative of this function here. So we can say that the derivative of the function is indeed equal to, let us say, x minus 2 to the power of 4 over x minus 5 whole cube times x minus 17. Negative value, so we'll write like this, negative value when x is less than 2, and positive this, which is x minus 2 to the power of 4 over x minus 5 to the power of 3 times x minus 17 for x greater than 2. Right? Does it make sense to you? Now there could be an alternate approach to this solution, right? So let me mention here alternate approach. The alternate approach can be that if we have a function f of x equals to absolute value of x, then the derivative of this function is x over absolute x, where x is not equal to 0. And this could be written as signum x, correct? Where x is not equal to 0. Okay? So that is how you could actually write derivative of your function. So using this rule, right, we could actually find derivative and write an alternate solution. So let me write down the alternate solution right there in terms of signum function. So we could write p dash x as equal to, so the denominator here is x minus 5 absolute value to the power of 8, right? We are using quotient rule. Derivative of numerator, which is power rule first, 5 absolute value of x minus 2 to the power of 4 times derivative of this, which is signum x minus 2, right? Times the denominator, which is absolute value of x minus 5 to the power of 4 minus. Now derivative of denominator is 4 times absolute value of x minus 5 to the power of 3 times signum x minus 5 times absolute value of x minus 2 to the power of 5, right? So that becomes the derivative of your function. You can always simplify this, taking whatever is common, right? Some absolute value of x minus 2 to the power of 4, right? So to the power of 4 times absolute value of x minus 5 to the power of 3. We have this denominator here, x minus 5, absolute value of 8. And what you get inside is 5 times signum function x minus 2 and the absolute value of x minus 5 minus 4 times absolute value of x minus 2 times signum function x minus 5. Correct? So you could write your solution in this fashion. Yes, of course, you could cancel this with 5 and get a similar solution. So that becomes an equivalent solution for the derivative of the given function. Right? You can use signum function. So I hope the concepts are absolutely clear. Feel free to write your comments and share your views. Let me get back to the original function which we started with. So what we really understood in this video is the absolute function, which, let me summarize, can be written as a piecewise function, right? So x when x is greater than 0, or rather equal to 0 also, minus x when x is less than 0. We also know that the absolute value of x is indeed equals to square root of x squared. We found that the derivative d dx of absolute value of x is x over absolute value of x, or signum x, let me write here, where x is not equal to 0, correct? So that was the derivative. So this derivative was here, written here. And the derivative, g dash x, when it is translated, could be written as x minus 2 over absolute value of x minus 2, right? So we know it is also not defined when x equals to 2 and could be written as signum x minus 2. Is it okay? SG. Now, for the power of 4, we found that the derivative could be written as h dash of x equals to 4 times, we just applied the power rule. And we found that this could be written as x minus 5 whole cube, right? X minus 5 whole cube, which resulted into the solution as 4 times x minus 5 whole cube. Do you see that? Since that is equals to x, absolute value x minus 5 to the power of 4 is x minus 5 to the power of 4, right? And this was very interesting as we found that derivative to be 0. And this, as we showed you, could be solved using the signum function or using the piecewise function. So I hope you understand and appreciate the approach. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.